Hi, my name is Carl Grayling. I'm a founder member of Gatfol, a language semantics technology startup with core algorithms patented in the United States in 2011. We have developed API cloud solutions into around 25 large application fields. Gatfol exists to make the jump from current keyword technology to a more human-related form of database querying. In this video, I will highlight the basic language semantically related problem in each application industry, and then cover the specific Gatfol solution to that problem. As background, I will also open up a slowed down annotated window of one of the Gatfol master and slave Hadoop style agents. You can see this here. This will provide a glimpse into the actual live Gatfol semantic processing whilst I am speaking. Hopefully this will turn this communication into more of a video rather than a podcast. Okay, in online retail it's difficult to get search return items to rank logically in terms of the search keywords because almost all systems purely add keyword hits into catalog items and return most hit returns first. Results can semantically be wildly off the mark. Our web example shows nylon underwear with cotton trim and body hugging line as a return for nylon trimmer line, because we have 100% stemmed hit count on all the search keywords. In many instances, search return rankings are so bad that clothing results mixed with food, mixed with hardware, mixed with party supplies, all for the same search phrase is not at all uncommon. Gatfol processing throws search keywords semantically together with each catalog database return. It can be up to thousands in many instances. And look at keyword cohesion. Around 40 different algorithms are used to move less relevant returns down or optionally mark them for non-return. And this is all within a few microseconds, fully in line. A second problem in online catalog search is that returns for a certain set of keywords are not always the same as for another. Let's say grammatically different keywords, but semantically equivalent to the original. As an example, we have kids soccer boots as search input versus children football cleats. We all agree that the product return should logically be the same or at least overlap substantially. This almost never happens. In many of our test results can vary as bad as 1 return versus 100 returns for semantically equivalent searches. With any search of at least minimal complexity, it is almost impossible for the online user to guess groups of synonyms to replace, delete from, add to, or make any other change to the input on a continuous basis. The Gatfol API steers client search requests through the Gatfol cloud processing, where from thousands to millions of multi-word equalization operations are performed on the keywords, all in real time, to return semantically optimized search phrases that hit catalog database entries in parallel. Now let's move on to classified advertising. Here we see the same ranking and synonym replacement solutions to very much the same problems as in online retail. In fact, with online classifieds, the problems are actually magnified in that database content is mostly supplied by the ordinary man in the street advertisers at much higher volumes per day and with more semantic spread, as opposed to more limited catalog products listed through in-house product aggregators. Our ranking example here is on search for, let's say, laundry basket, with returns carrying both laundry and basket, but wrapped in the different phrases with laundry room and with beautiful external flower baskets relating to a property for sale ad. Gatfol, inline and in real time, semantically evaluates the keywords laundry and basket to each and every ad return, using around 40 different comparison algorithms to return as output a far more relevant ranking order. Our synonym example is for a search on brick and brack that does not return any ads for homeware trinkets. Gatfol does expansion, again inline and in real time, to create the keywords homeware trinkets in stealth. This is then used as database input to return ads on aggregation of hits. In the field of media and news, ranked search returns is a common occurrence and in itself generates more news from research, studies, follow-up reporting, etc. The search words crazy shooter politician equally brings up media articles on gun violence as well as on video or photography shoots. Gatfol compares victims named okay, let's look at an example. Sorry about that. Gatfol compares headline returns such as Tarantino declares death of cinema at Cannes and California shooting spree victims named at very deep semantic levels to the keyword input to mark down cinema, Khan and Tarantino, and mark up shooting and victims, in relation to our original search input, crazy shooting politician. Note that semantic groups of all dimensions are internally delimited by Gatfol and used in very fine evaluation. Our synonym example is for pop icon on stage versus music star live performance, where the latter returns a whole line of articles that the former does not. Note the disparity in keyword counts between the two input phrases. The special power of Gatfol is that it semantically equates 1 word to 5, 7 words to 3, 3 words to 4, 4 words to 1, any possible permutation in fact. Our next application industry is in business intelligence, a wide congregation of solutions ranging from broad data visualization to narrow search tools into focused industries. A large proportion of business intelligence involves search, and again the main desirability here is to create multiple semantically equal search phrases from just one phrase. This can then all be simultaneously pushed back into data aggregation to return a far more powerful search. As an analogy, we can think of using 1,000 magnifying glasses as opposed to one to search for that proverbial needle in a haystack. Next we look at web search, and mainly browser-related search. We have all been through the experience of getting inferior or inadequate returns on a web search, and after some keyword additions, deletions, amalgamations, and word group condensing, we eventually find better returns. Gatfol takes all this work away from the online user, in stealth, without any disturbance in the search communication flow between user, browser, and search engine, and again at massive speed and at very high relevancy and accuracy. The Gatfol functionality in big data analysis is quite straightforward if you look at the examples we've already discussed above. Massive semantically equalized parallel search from Gatfol are pushed to hugely increase the stabs into very large data sets. With Gatfol, single keywords become hundreds, with returns possible that would have been semantically missed before. Next, we quickly look at augmented reality, a currently very trendy and active field. With augmented reality technology, input is restricted because of the small size of augmented reality equipment, as in i.e. a smartwatch, or in the physical access difficulties, as in wearable smart glasses. Voice command input is crucial here, but what back-end technology will semantically equate the phrase "where am I" to the phrase "produce a map"? This is where Gatfol comes in line, in stealth, and in real time. We're all starting to talk to our household appliances and cars, for instance. Even if web connected, the appliance backend technology will not carry the semantic reach to, for instance, equate the voice return of "it is sweltering in here" to "air temperature down" in relation to a home air conditioner. Gatfol links voice instructions to appliance function, again quickly and accurately. Next field we're going to look at, electronic search used by the security, national intelligence and surveillance industries, is normally constrained by danger word blacklists, with the obvious problem that semantically close but grammar-wise different non-blacklist words are not picked up. Gatfol creates these semantically similar words in real time and inline to provide a much larger catch net for magnitude increases in results accuracy. Another field, in child-friendly online environments, the threat of abuse is always real. Although a large amount of language filtering is applied today, very bad things can be said with very innocent individual words. Gatfol is not constrained by danger word lists and use extremely powerful heuristic, algorithm-driven word patterns to keep online discussions clean and safe. Auto-tagging of video and images is an incredibly attractive industry, serially tackled every year through many research developments of practical applications, but unfortunately is extremely difficult to get right. We have seen many approaches faulty in the commercial space in the last few years. Current pixel analysis technology can create, for a specific image for example, a fairly diffuse cloud of concepts, of which some relate to others semantically, some do not, and some are related in complicated ways in groups. Gatfol uses multi-word to multi-word semantic equalization and elimination to discard tags that are semantically irrelevant to the main groups of tags. As an example, the word blanket becomes beach towel when we have sea and sand as ancillary group tags. Again, Gatfol cloud-based Hadoop-style master and slave processing is so fast that massive volumes of processing can be augmented inline to make even real-time video tagging a reality. To centrally control the content entering and exiting enterprise communication networks is a very attractive goal. This is the next industry field we're looking at. The problem is that semantic equalization systems nowadays run across huge server sets and require massive processing memory and storage space to support large ontologies and dictionaries. A full-strength Gatfol employment can run on as little as 3 GB of RAM with as little as 50 MB of disk space, and again on single chip processing. Gatfol is also operating system independent, can be employed as ontology inclusive, simple executable files. This means that Gatfol can easily run as an embedded semantic firewall in router hardware centrally inside large networks. Malicious or accidental corporate data leakage, our next field, can be extremely costly. Data leakage is again controlled through danger word blacklists, and blacklists can be circumvented on purpose or by accident. Anybody can easily use substitute concepts equal in meaning but grammar-wise different to the original. Gatfol again steps in real time and inline to semantically negate and close obfuscation of opportunities. Next field, semantic product and launch analysis, sentiment analysis, in other words, especially for large worldwide conglomerates, is a fast-growing online industry linked to real-time response feeds such as Facebook and Twitter. Machine analysis of sentiment is mandatory when response data is of immense volume and high throughput. Machine sentiment analysis can be very difficult even for humans. A statement with several opinion words like hate, dislike, want, prefer, avoid and recommend can be difficult to summarize into final sentiment. Gatfol uses its multi-word to multi-word equalization technology to make this analysis easy. Next field we're looking at, many corporate in-house data streams, from telephone conversations to email to personal interviews, are nowadays aggregated to provide customer relationship insights. Because Gatfol can work across massive word groupings, it is ideal to use for large parallel search when combining information sets of different structured and unstructured makeup, and across many modalities including voice and text data. Next field, content filtering at ISP level, is becoming far more prevalent with many government statutory requirements, and this will be growing in time. A practical problem is that beneficial content is sometimes blocked when we use only keyword aggregation as our filtering tool. The example here is that of the words breast and minor and children, triggering a false positive block when the online content relates to breastfeeding of children below the age of 5. Gatfol does not use simple keyword aggregation, but much more powerful, proprietary, patented semantic multi-word technology to minimize false positive. Another interesting field, is intelligent assistants like Apple Siri. These are very much language content driven, both at input and output levels. We again have the disparity in the immense amount of ways the human brain can formulate a single phrase and the relatively limited language processing permutations of the back-end technology that the back-end technology can carry. To another human being, the instruction to fetch a map is instantly semantically equitable to show directions, but to machine processors set at keyword aggregation level, it is not. Gatfol bridges that gap at microsecond input-output level. Next field, email spam filters struggle to cope with marked spam tokens that are semantically replaced with different words. As adaptive algorithms train over fairly long time cycles, this is a substantial problem. Gatfol technology heats all the semantic replacements as spam tokens as well, and email with mail enhancement pulls will be equally likely to be marked as junk than a mail with performance tablets for men. Another field, online plagiarism. Checking across all levels of education provision is a very robust industry. Prior occurrence of groups of words is very difficult to pick up when specific keywords are replaced by semantic equivalents. Gatfol covers all forms of keyword replacements at throughput volumes of many megabytes per second. Lastly, we look at the very important online industry of dating or matching sites. It's a multi-billion-dollar segment of the online commercial world, and with a lot of personal characteristics matching done through semantic connections. Gatfol plays a crucial role in making sure, for instance, Jill is listed as a possible romantic match for Jack when she likes horse jumping and dressage, and he likes equestrian sports. This brings us to the end of this video. We've skipped some lesser application industries. I think, although that the main Gatfol functionality across many online fields were quite clearly shown. Thank you for listening and watching.